Hey everyone, it's Ben from Vertices, and welcome to part 8 of our series on making a procedural mesh in Unity. So we're going to move on now from our basic quads and grids into making cubes. So what do we know as we start planning to make this cube? We know a cube has 6 sides, so we're going to need 6 quads in order to make it. We also know that we're going to want to use separate quads, each with their own vertices, because we're going to want hard edges. Otherwise, this is going to look more like a very poorly modeled sphere. So that means that we're going to have a total of 24 vertices. However, there's only actually 8 unique vertex locations because each corner of a quad is going to be sharing the same location as 2 of the other quads in the cube. So how do we want to position and rotate these quads so that they fit properly on our cube? We have 3 options really. The first one is that we could actually hard code all 6 quads and give the exact vertex positions and the triangle index arrays for each of those quads and then just kind of dump them into the cube as we need them. Another option was that we could procedurally figure out the positioning and rotation of each quad at runtime as we're building the cube itself. Lastly, we can kind of split the difference where instead of hard coding all of the quads, we can just hard code those 8 initial vertices we need and then know the proper order that each triangle needs them, and then we can just kind of feed those into our quad function so that we're using the existing quad function that we have, making those 6 quads, but not having to hard code everything all at once ahead of time. That's actually going to be the track that we're going to take with this, but what's really key here now is what we need to decide is how we're going to store those 8 vertices and the triangle information. And it's really kind of an arbitrary thing at this point because you could choose any particular order to store your vertices as long as you're properly doing the clockwise triangles for each quad. So this is the system that I use. This was kind of done based on trial and error. Feel free to, if there's something else that works better for you, that's totally cool. I use a north-based system for my cubes, where north and south are the z-axis, east and west are the x-axis, and up and down are the y-axis. So in my vertex array, the first 4 vertices are the vertices of the north face, and the second 4 vertices are the vertices of the south face. And then from there, everything else kind of builds around those. So let's jump into Unity and I can start kind of coding this in and showing how all of this is going to work. So here in Unity, I'm going to create a kind of a helper script, create a C# script. I'm going to call this cube mesh data. This is ultimately this isn't going to do anything, but it's going to be a static class that stores some information for us that we can access in our procedural cube script that we're going to create in a little bit. So in here, I'm going to make this no longer inherit from mono behavior because it's not going to exist in our scene. But I'm going to make this a static class, so it is going to be accessible from anywhere that we need it. We can delete the start and update functions as they're no longer relevant. So inside of this class, we're going to be storing 2 arrays. The first one is going to be a public static vector3 array called vertices. And this is going to store 8 total vector 3s, which are our vertex positions. Now, as I said before, the first 4 of these vertices are going to be the north face of the cube, and then the second 4 are going to be the south face of the cube. Why that's important is because that does tell us at least that we know that the new vector 3, we don't. For some reason, Unity loves to add the brackets inside of here even though you don't actually want them. So the first vector 3 we know is going to have some kind of number for x, some kind of number for y, and then a positive 1 for the z. And these are not actually, these are going to be either 1 or negative 1, but that's kind of a placeholder for now. But we know it's going to be positive because we want it on that north face, that positive face of the positive z face of the cube. And we know that the first 4 are going to be like that. So I could copy this and say paste, paste, paste. And then we know that the second 4 are going to be the south, so we can do the same idea, but make these all negative. Negative, copy, paste, paste. Ugh, that jumped on me. Paste, paste, paste. and we can get rid of that last comma. So that sets up the first, we know that first side. Now our Y positioning is going to be the first two are the top two, because kind of if you recall how we were tending to do the cubes, we're going to draw them out like we're drawing a square, starting on the top side and then going down to the bottom two vertices. So we know that this is going to be 1 and 1, this is going to be -1, -1, and likewise for the second two, 1, 1, -1, -1. So that kind of pattern. So it's 4 and 4, and then 2, 2, 2, 2. X unfortunately kind of breaks up this pattern a little bit, and that's simply because of how the order of you're drawing the triangles is. But so this is kind of arbitrary at this point, but we're going to put this in as 1, -1, oops, -1, 1, and then -1, 1, 1, -1. So here, I'm going to actually break these up a little bit so they're a little bit more even here. So here, I'll leave this up for a second so you can kind of see how the breakdown is. Again, this is really an arbitrary order that I chose because I liked how it worked, but ultimately, as long as you're consistently making your quads in the proper way of having your clockwise triangles, you can do this however you want. For our second array, we're going to be putting in an array of arrays, which is going to be the sets of integers which tells each quad which vertices it needs to refer to. So what I can do here is I can say public static int. We're going to put two sets of brackets so we know that it's a nested array. And I'm going to call this triangles equals. Actually, I'm going to call this face triangles because it's not just individual triangles like we've been normally dealing with, but it's for the full face of each side. And this is going to be because it's a nested, you actually have to say new int. And now in here we can say, oh, actually, sorry, no, I'm doing that wrong. Set up our brackets as, because this is an array, and then each one inside of it needs to say new int, and then establish the array inside of here. And these are going to be 0, 1, 2, 3 for the first one, because that's our north face, and that's just using, like I say, these first four. The second one, the order again, totally arbitrary, the order I do my faces is north, east, south, west, which is clockwise around the compass, and then I do the up and the down faces. Again, this is a thing that you can do in whatever order you want, as long as you're consistent. Now I'm going to copy this, because it's going to be the same structure for the other 5. Delete the last comma. And now second one is going to be 5, 0, 3, 6. And if that seems kind of random, what you can do is you can look here and say, what's the fifth? The fifth position is +1 here because it's the east side. 0 has a +1 in the x because it's on the east side. 3, +1, and 6 has a +1. So you can kind of tell once you're doing these that it's relating to which side, all of a given side are going to be the same position because they're all on that one face. In addition to this, you do need to keep track of the actual position so that the triangles are being drawn properly. But again, that's kind of a thing that you can do by trial and error. This is the way that I ultimately found works best. Now we're doing the south face, which is going to be just these last 4. So that's going to just be 4, 5, 6, 7. The west side is going to be the opposite of these. So it's 1, 4, 7, 2. And that's the other way you can kind of check these, is that your opposite faces should never be using the same vertices. And then 5, 4, 1, 0. And lastly, 3, 2, 7, 6. So the last thing we're going to add in here is a way to access an array of our vector 3's based on the direction we're facing. So what we're going to do is we're going to say, I want, we're going to pass in an integer that references one of these directions. So say direction number 2, please get me vector 3, 4, 5, 6, and 7. And then it will return an array with those 4 vertices. It's relatively easy to do. We're going to create a public static method here, and it's going to return a vector 3 array, and this is going to be called face vertices. And it's going to take in an integer dir for direction. So inside of here, we're going to create a vector 3 array called fv, and that is going to equal a new vector 3 with a size of 4. Now inside of here we can say 4 int I equals 0, I is less than fv dot length, because we're going to want to iterate through each slot available in the array. And then we can say fv in index I is equal to face triangles. And remember, this has now 2 levels of 2 arrays here, 2 nested levels of arrays. So the first one is going to be the direction, and then the second one will be whichever particular position in the direction. So the iteration of this array. So now what happens is, if we pass in 2 here, it's going to say, okay, I'm going to create a new array, and then each index of this new array is going to be equal to the index in the proper one of these arrays that I'm calling on. So that's a bunch of data we've just kind of dumped into here, but it's going to make our jobs a lot easier as we're actually building the cube, which we're going to do in our next script we create here. So for our second script, we're going to create a C# script, and we're going to call this Procedural Cue. And this is going to work very similarly to our procedural grid, so we're actually going to open up both of these scripts in MonoDevelop, because there is going to be some stuff that we're going to steal from procedural grid. First and foremost, we're going to take this require component. We're going to put that right at the top here, because we're again going to be attaching this to something with a mesh filter and a mesh renderer. Also going to take all of this information here, and copy that, paste it in here, as well as our start methods here, our start and awake methods. Oops. Copy that, get rid of these 2. And lastly, we want our update mesh method as well. We can change make contiguous procedural grid, because we're not doing that any longer. We're instead going to say make cube, and that's a method we're going to have to create down here, void make cube. In addition, we're also going to have a separate method called void make face that make cube is going to call multiple times in order to build itself. Now, the last thing I'm going to do here is, when we were creating these grids and quads, it was very kind of, because it was all on one plane, it was very easy to create, say, an array of information and just be done with it. Now it's actually going to be a lot easier if we work with lists, because we're creating a face, adding it on to our cube, creating a face, adding it on to our cube. We're not dealing with really... It makes our job a lot easier if the vertices and the triangles are kind of malleable. So what we're going to do is we're going to add using system.collections.generic, and that's going to give us access to lists. And we're going to change our vector3 vertices and our vector3 or int triangles arrays here. We're going to change those to lists. So we're going to say list vector3 vertices and list int triangles. You'll note right now I am not creating the list here. You could. I'm actually going to do that inside of the make cube method, because if we were to change it, I don't want it to start building new vertices on top of old vertices, so I want it to kind of clear itself every time. Likewise down here though, our mesh.vertices is an array, so in order to add vertices and triangles to these, I am going to quickly say .toArray, so that we convert once our lists are done and baked, we can convert them to an array before we port them over to our mesh renderer, or to our mesh data rather. So inside make cube, the first thing we're going to do is we are going to initialize our two lists. So we're going to say vertices equals new list vector3, and triangles equals new list integer. And from here, we're really just going to be calling this make face. This make face method is really where the bulk of the work is going to be done, because that's what's actually creating the quads. So we're going to simply call that 6 times for the 6 faces. So we can say int, or for rather, tab twice to automatically populate this. I is fine there. However, we're going to change max to be 6 because there are 6 faces to a cube. And we can simply say make face, and this is basically the simple structure of how we're going to create the cube. Now we need to give our make face some information so that it can actually know which data to get from our cube mesh data class. So let's put in some parameters here. The few parameters I'm going to put in, the first one is just simply going to be that I, because that's going to tell it which sorry, keyboard's going a little crazy on me, which face we're dealing with, because remember we're going I0 through 5, which lines up nicely with that we have 0 through 5 in our face triangles. So we can simply say give it that I value to tell it which direction it's building at this time. In addition, I'm going to pass in the vertices and triangle. Oh, actually no, I don't have to do that. Sorry, I'm thinking of a different way I was building this. All we need to pass into it is the direction. So down here, in our make face method, we can ask for this parameter, which I'm going to call int dir for direction. So inside our make face method, we're now able to pass in this information, and we can pass it to the cube mesh data method we made earlier, and simply add that range of vertices to our overall vertices list. So we can say vertices.addRange, and the collection that we're going to be adding is an array, which comes from cube mesh data dot face vertices, and we can simply pass in that direction. And so that's going to pass in the 4 vertices we need to make the proper side of the cube. So when it comes to our triangles list, we know in the past we've kind of used this basic system where we say something like triangles.add. Now that we have the list, we're able to just use add and add these in rather than populating each index of the array. But we can say something like triangles.add 0, triangles.add 1, two for the first 3, and then keep that 0, 2, 3. Unfortunately, what this would do right now is it would simply reference the first 4 indices of our vertices array. We need to obviously account for the fact that we're adding to our vertex list each time. Fortunately, we can do that pretty easily because we know, for example, that once we've added the first range, we now have 4 vertices in the list. So 0 is really we want to make sure it's the first one, so it's the vertices dot count minus 4, because the count is 4 minus 4 equals 0. Likewise for the second one, that's this same idea, vertices dot count minus 4 plus 1 minus 4 plus 2, simply minus 4 again, minus 4 plus 2, and minus 4 plus 3. Now you could obviously eliminate an operation and make this just minus 3, minus 2, minus 2, minus 1. But for the sake of clarity, that's why we're keeping this way. But now this is keeping track dynamically because we know the vertex count is the same. What we can actually do too is we're going to create a quick int called vCount up here, make that equal to vertices.count. So rather than calling this every time, we can then simply just refer to this vCount, which I can actually do by deleting that. There we go, vCount. So now this is dynamically going to change based on the number of vertices we've added in. So now that we have all of this, we are officially building our faces. We're calling the make face 6 times based on the direction, and then based on the direction we're taking the proper vertices that we need and adding those triangle information as well, the vertex to triangle indices, to our information. And then we're simply updating the mesh as usual. So if we hit save, jump back here, and we'll delete this. Actually, we can simply remove this component and add our new procedural cube, and we should now see a cube appear here, and it's going to be 2 units by 2 units. So let's hit, we've got some error. Cannot implicitly convert. Ah, that's why. And I'm actually not even returning something here. I did a very poor job with this function. So we want this to actually return our vertices at this index. So we need to say vertices at this particular index, and then we need to return fv after all that. So now, let's see here, do we have any errors? No errors anymore, excellent. Now we can hit play, and we should see our cube in fact appears. Now obviously this is a very big cube right now, it's a 2 by 2 cube because we're going from -1 to +1 on every dimension. But this is really that same idea as how we built our quad originally, and now we can easily scale and position this mathematically through our code and create procedural cubes wherever we need them. So in our next video, we're actually going to look at how we can take this single cube and start using, looking at data and building cubes where we want them in a system that's typically called a voxel system. So thanks for watching, and I'll see you next time.